So I spent a lot of time today to understand the implementation of long-term memory in LangChain, which is named as Langmem. So it's a long-term memory that allows agents to remember important information across conversations. And there are three types of memory: semantic, episodic, procedural. So today I spent time to understand the implementation of semantic memory, and this is what I'm going to actually uh, explain how that implementation works in Langmem. I actually went through the Langmem open source code also to understand the inner working of this one, right? Um, so we'll look at it through a program. So what I did is I wrote this program and I created a custom memory store in SQLite. So in the example, it was an in-memory store, but I wanted to actually see how to persist that memory in a database. So here I use SQLite, and we'll also go through how I created this um, custom memory store using SQLite. So if okay, so let me go through this code. So this is my chat agent with semantic memory class. SQLite store. This is the class here, and we'll go through this as well, uh, this code as well. But this is the SQLite store class that I extended from the base store class of LangGraph to create the custom memory store, right? So this is that store. The namespace uh, is the collection, basically name of the collection where uh, I'll store the memory, right? So it identifies a particular um, uh, the memories that I stored for a particular user ID. So namespace is kind of an identifier for all the memories stored for that particular user ID. This is, if you see in the SQLite store, this is kind of a column that I put in the memory store. We'll take a look at it. Then memory tools, right? These are the two tools which are core to this the management of the semantic memory as well as searching the memory, right? It's kind of like how Langmem implemented it is uh, through a tool usage. So memory is being considered as a tool here, right? So if I go to this particular function, um, create manage memory tool, it takes namespace as one of the input. Instruction is where it says proactively call this tool when you identify a user preference, right? These are the instructions given. Um, then action permitted, either you can create, update, or delete a memory. Store is the memory store, and the name of the function string is a manage memory. This is what the language model uses when we give the tool. It uses this name to determine which tool to use based on the question, whether to search the memory or to create or delete the memory, right? And within this, there are two functions. Actually, yeah, one function, sorry. So it's manage memory, right? One is the async version, the other one is the non-async version, right? So both of them are, the logic is more or less same. Manage memory takes content, which is the query asked. The action is create, right? And then based on So since it's a managed memory, right? It is a put operation, right? So it says store dot put, gives the namespace, creates a key, and the value is the prompt, right? Now this put, store dot put, is um, something that uh, we have in the memory store, right? So after store dot put, if I go to the store, right? So I should actually see this function. Let me, yeah, the def put, right? So I go to SQL store, which I created. Oops. Okay. No, so here, okay. So okay, let me go back here. We'll come back from here, right? So this memory store, the put function, the put of function, manage memory. Yep. So if the action is, so it is a put function, right? So the put function is in the store dot put, right? So okay. So okay. So if I go to the base store, right? It calls the base store put function, right? Namespace, value, the index, right? That we give. And here it calls the batch function in the parent class, in the parent store class, right? This is what I have now implemented in my custom store. So if you see the custom store, the base store, but so when I call the put, it calls the batch function of SQLite store, right? So if I go to the uh, batch one, yeah. So here, when okay, so when it did a dot put, right? So where did that memory go? Okay, let me go back to the memory. Right? So when it did a dot put here, this dot put is for adding the memory on the store. This put is the put function in the parent class, which is base store, and the parent class in the put store calls the batch function, right? Which I, for the custom SQLite store, I coded this, right? So here, for op in ops, right? What is the operation, right? So if it's a you want to retrieve in memory, then it's a get operation. If it add, it's a put operation. Other is a search operation, right? So if it is a put operation, right? What it does is it doesn't upset it. It says if my memory is already there. If okay, so first of all, like yeah, so if it is uh, it's an upsert. If the memory is already there, it will update it. Otherwise, it will insert it. This is the on conflict thing, right? So here I insert into the store, into the memory store, the namespace and namespace JSON. The key, it's a UUID, unique ID created. The value JSON is the where the content is stored. Embedding, what I did is the content I embed and put in embedding, right? So that when I search, I can search, do a semantic search on the embedding and see if the similar prompt or question is there, right? And the created and updated that is there, right? So this is how when I ask a question and say memorize, the create manage memory tool gets triggered. It calls the put on the store, which then calls the batch thing that I created, right? And when I instantiate this SQLite store, here you'll see that during instantiation in the init method, I connect to the SQLite store. This is the name of my store. And then I create the table also, if it exists, the memory store table, right? Similarly, like the put, there is the under batch, you'll have the search operation also, right? If the search operation, I select all the memories for that namespace, right? And then I embed the query, right? I embed the query here. And for each row in that namespace, I calculate the cosine similarity between the query embedding and the candidate embedding. And then uh, basically like I sort, and then I can find out which is the highest score and then give it back to the user, right? This is how I coded the SQLite memory store here, right? So now going back here, so we give create manage memory and create search memory tool. If it is to search, it will use this tool. If it is add, it will use this tool. And we saw that how it calls the put on this one. On the search one, it should be the search operation, right? Here it will do a search, right? Store.search, right? And store.search. And if we see in the base store again, the search would call the batch itself, self.batch, right? So that's how it is working. Now, let me go through the rest of the code and then we'll run it, right? So I created a get agent function, and here I'm calling the create react agent, which is a pre-built agent in LangGraph, right? Which takes the model that I want to run, the tools, right? These two tools, these two memory tools is what I'm passing. Store is my memory store, which is in SQLite, and the checkpointer is an in-memory checkpointer, right? And returning agent. Then the main method, I instantiate this class, I get the agent, and then I loop until the user is done asking all the questions, right? So here I take the user input. Here I hard coded the thread, but it can be for each new session, it can be a different thread, but I hard coded to thread one, user A, right? And then I invoke the agent, print the result, right? So we'll run this and then we'll see how the memory gets added, right? I also added Langsmith. We'll also go to Langsmith and see how it looks like in Langsmith, right? So let me run this. Okay, so yeah, let me stop and run it again. Oops, it became very slow. Okay, let me delete the memory file. I'll recreate the memory file. So let me execute it again. So now ask your query, right? So you'll say, where is Taj Mahal? Now to for it to use the memory tool, I'll say, please remember the answer. So if I now run it, we'll see that, okay. So put operation, right? And there was a search operation. In the search operation, it could not find anything, right? But it would have stored it in the memory. But let's ask one more, and then we'll see the memory, right? Where is let's say, I'll say, where is uh, Qutub Minar? Also remember this answer. And now let me exit out of it after it is done. Exit. So my memory should be coming up here, the memory store. It should create, it has created. Now let me go to the SQLite viewer. And this is the SQLite. And if I open it, I should see two memories, right? This is first memory. This is the second memory, right? And this is the embedding of this content, right? Now, the next thing I have not tested. So let me see if how it works. So I have two memories now, right? Where is Taj Mahal and where is Qutub Minar? We will ask this question again and we'll go to Langsmith to see how it is answered. But the ones that we ran recently, let's open this one first. So we ran two, right? Where is Qutub Minar? Where is Taj Mahal, right? So here, if we see how it worked is, so let me collapse this. So there are three things, right? First, the create React agent is actually LangGraph code, right? Where it has agent um, and uh, uh, a conditional age, either it uses tool or it ends giving the answer, right? So here, if you see the first one, should continue. This is the conditional age. This said output is tools, right? And there are two memories it is given. So next in the tools, it picked up this. So the manage memory and the search memory, it could not find anything, right? So uh, it will go and see created memory, right? So it created the memory here, right? After that, should continue would be, so it will, next GPT-4 will give the answer. The Taj Mahal is located in um, the created memory and give the answer located in Agra, right? And the should continue is end, right? This is how uh, the earlier conversation that I did, right? It came, right? Like this. Now we know that these two answers are there in the memory. We'll see if it picks up from the memory. So now when I will run it again, and this time I'll say, where is Taj Mahal? Answer from memory if available. Okay. So if I run this, see, it has done the search operation. I'll exit out of it. Go back to uh, the tracing project. Let's see when it was run. Sometimes it takes time to come. Yeah, so they just come, right? So let's see what it did. So this time it says should continue tools. It says I want to use tool, did a search memory, and in the search memory, it did find it, right? And it gave me from the memory. Answer came from the memory. This is the answer, right? And then should continue. Since answer is there, it ended it, right? So yeah, so in this case, it gave me from the answer. Let me try one more where it is not in the memory. then it should actually not call any of the tools, right? So I'll say, where is Statue of Liberty? Where is Statue of Liberty? Since I did not ask it to memorize, it will not memorize. Let me exit out of it. Now we will see if I go to the tracing project. Yes, this is the one. I should not call any of the tools ideally. Yeah, only one agent, and it directly answered from through the model, right? One more last testing. We'll see, where is Statue of Liberty answer from memory is available. This should, yep, search up. And if I exit out of it, go back to Langsmith this time. Yeah, this time I should see a tool call. Yes, there is a tool called search memory call, and we got the answer from. So let's see what it gave the answer. I see Statue of Liberty, right? Okay, so I think the search memory, it probably, this is strange. I don't see the Qutub Minar. Where is the other one? It did give me the right answer. Statue of Liberty location, agent memories. Okay, let me. This is strange. This I'll have to investigate, because the Statue of Liberty. Okay, so the Statue of, okay, I understand what has happened. The Statue of Liberty we never stored in the memory, right? So when it got this answer, right, or got the memory, it did not answer from the memory. Actually, this came from the directly from the model, right? But if I would have, let me run it again, and this time what I'll do is I'll store it in memory, then ask the question, where is Statue of Liberty? Remember the answer. Right? So it will now do a put up. Right? Did a put up, exit out of it. I should be able to see this in the memory now. If I go here and run it again, or upload that memory file, let me upload the memory file. I should see the Statue of Liberty also as in memory. Yes. Now, if I ask the question, I should be able to see it in memory. Where is Statue of Liberty? Answer from memory if available. So this time search operation, exit out of it. Let's go to Langsmith tracing project. This time I should be able, oops, I should see in the memory. So in the search memory, I should see that it pulled up Statue of Liberty came at the top. The score is 0.69. For the others is very low, right? And this answer will be from the memory, right? So let me see what was in the other one, how it looked like for, yeah. So here It was not from memory, right? So no, it was also, but it did not, it extracted the memory, but it did not answer from the memory. Uh, but oh no, this one we ran to put in memory. The previous one, I wanted to see whether it searched the memory. Yeah, it did search the memory. It did not get anything. So it actually says the memory does not contain information about the location. However, this okay. So this now explains everything, right? So once we uh, uploaded, or once we asked it to memorize, then it uh, gave it from the memory. Okay. It was here, there in the memory, and the answer was, so in this, based on its memory, it answered it. Right? That's how the semantic memory is implemented. Now, I have a different view on how it should have been implemented. My view, my perspective on how this should have been implemented, probably I'll share in a different recording, right? Because the idea of memory is to also see how can I avoid language model call to reduce cost and be more consistent, right? More deterministic. In this um, implementation, the recording that so here we are still using the language model to actually use a tool to memorize, which brings some bit of non-determinism, as well as when we get um, the memory content, I'm using another language model to actually look at that memory and give me the answer, right? So it doesn't help me to reduce the cost of LLM. I should be able to see, okay, if the memory matches my new query, I should directly give it from the memory. I think that probably is possible, but the use of tools to extract the memory and then store the memory, I think that part could be made more deterministic um, by implementing more syntactic way of creating the memory service. That's all for today. Thank you.